Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular video is AQA New Practice Set 1 Foundation Tier Paper 2 Calculator. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. How many grams are there in 2.5 kilograms? Circle your answer. Well, I know that 1 kilogram is 1,000 grams. So 2.5 kilograms is going to be 1,000 times 2.5, which is 2,500, isn't it? It's going to be that. Okay, question 2. Which of these can be written as A over B? Circle your answer. Well, A over B is literally A divided by B, isn't it? So it's that one there. Question 3. Solve 12x equals 3. Okay, so we've got an equation in x here that we need to solve. So when we've got an equation like 12x is equal to something, if I divide both sides by 12, then I should be left with x. So I divide 12x by 12, 3/8 by 12. That will cancel with that, and it will leave me with x. And on the right hand side, I've got 3/12, or 3 divided by 12, which is the same thing as 1/4. So it's that one there. If you're not quite sure why that is, you can just put 3 divided by 12 into your calculator and it will tell you that it's 1/4. Question 4. What is the value of the digit 7 in 3.72? Circle your answer. Okay, so the 3 is in the units column and the 7 is in the tenths and the 2 is in the hundredths. So that 7 there is going to be 7/10. It's that one there, isn't it? Question 5. Write down all the factors of 18. When I'm looking for factors, I tend to look at them in what's called factor pairs, numbers that multiply together to give you 18. So 1 and 18 goes together. 2 times 9, 3 times 6. Right, now the advantage of doing it this way is that I know that I'm just now looking for factors between 3 and 6. Because I'm kind of coming at it from both ends, so all I've got to do is check 4 and 5 and see if either of those are factors of 18, which they're not, so I know that I've got all of them. So then all the factors are going to be 1, 2, 3, 6, 9 and 18. Question 6. A hotel charges £59 per night for a room. It charges £6.95 for breakfast and £12.50 for an evening meal. Now Liz stays at the hotel for 5 nights. She has 3 breakfasts and 1 evening meal. How much does she pay altogether? Okay, well, we've got to do several multiplications and then add up our results, don't we? So we've got, first off, she's there for 5 nights and it's £59 per night. So if I multiply 59 by 5, I should be able to work out how much he's paying for the room. So tapping that into our calculator, 59 times 5 is 295. Okay, so that's how much she's paying for the room. Right, next up, she had 3 breakfasts, and each breakfast was £6.95. So multiplying £6.95 by 3. Again, I can just type that into the calculator. That tells me £6.95 times 3 is equal to £20.85. Okay, so that's my breakfasts, and then I've got one evening meal at £12.50. So I don't really have to do any maths for that, do I? Just £12.50 lots of 1. That gives me £12.50. Okay, so then the total bill is going to be those added together, then, isn't it? It's going to be the £295 for the room, plus the £20.85 for breakfast, plus the £12.50 for the one dinner. Okay, so you just tap all that into the calculator again. So I've already got £20.85 shown from before, so let's just add on £12.50 and 295. Comes to a grand total of £328.35. 328.35. Okay, so that's my answer. £328.35. Question 7. The line graph shows the number of goals scored by a hockey team. So we can see that we've got number of goals along the bottom of the axes there and number of matches up the side. First question says, which number of goals is the mode? Now, mode means most, doesn't it? Most often occurring. So in terms of this problem, it's going to be the tallest bar on the graph. So that's that one there, isn't it? That's the tallest bar. So the modal number of goals was 3 because it occurred most often. It occurred 6 times. So mode equals 3. Oops. 3. How many matches did the hockey team play altogether? Okay, well, we can work that out by looking at the totals of all these lines, can't we? We know that no goals were scored in 2 matches, and 1 goal was scored in 5, and 4 goals were scored in 2, and 6 goals were scored in 3 matches, and 2 goals were scored in 4, 0 for 5, and 1 for 6. So if we add all those numbers up, we'll get the total number of games that were played. So total is going to be 2 plus 5 plus 4 plus 6 plus 2 plus 1. What's that then? 2 and 5 is 7, plus 3 is 11, plus 6 is 17, plus 2 plus 1 is 20. So it's 20 games altogether. 20 matches. In one of the matches, this team won by 5 goals. What was the score in that match? Okay, now we can see that no games had exactly 5 goals scored in them. So if this team scored 5, then the other team must have scored some as well. The only possibility is if it's this one here on the end. So if 6 goals were scored altogether, which means that the opposition must have scored 1 goal. That's the only possibility. So in one of the matches, this team won by 5 goals. What was the score in that match? It was 6-1. Question 8. A game is played with a fair spinner. You can see on the spinner it's got the numbers 1, 2, 3 and 4. They're all equally as likely because they're all exactly the same size as each other. The player spins the spinner twice. The score is the difference between the 2 numbers. Now, difference means in mathematics subtract. So you're going to subtract one score from the other. So complete the table to show the scores. So if I got 1 in the first spin and 1 in the second spin, then 1 subtract 1 is 0. If I've got 2 in the first spin and 1 in the second spin, then 2 subtract 1 is 1. 3 subtract 1 is 2, and 4 subtract 1 is 3. If I got 1 in the first spin and 2 in the second spin, then 2 subtract 1 is also 1. 2 subtract 2 is 0. 3 subtract 2 is 1, and 4 subtract 2 is 2. And I can just fill out the rest of the table in the same way. So 3 subtract 2 is 1, 3 subtract 3 is 0, 4 subtract 3 is 1, 4 subtract 1 is 3, 4 subtract 2 is 2, 4 subtract 3 is 1, and 4 subtract 4 is 0. So let's have a quick look then at the next question. It says, the player loses if the score is 0 or 1, and the player wins if the score is 2 or 3. Now Amy says 2 scores win and 2 scores lose, so the probability of winning is evens. Is Amy correct? Tick a box. Okay, so she's correct in that there are 2 outcomes that are a win and 2 outcomes that are a loss, but that's not necessarily equal chances of getting those 2 things. Let's have a quick think about this. What's the probability of getting a 0 or a 1 in this game? Well, probability is equal to successful outcomes divided by total outcomes. Now there are a total of 16 outcomes here. I've got 4 rows of 4. And how many of those outcomes are 0 or 1? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's actually 10 outcomes that are 0 or 1, giving you a probability of success of 10 out of 16. Whereas the probability of getting a 2 or a 3, how many of those are there? I've got 1, 2, 3, 4, 5. I've only got 6 of those. So the probability of getting a 2 or 3 is 6 out of 16. So she's far more likely to get 0 or 1 and therefore lose than she is getting a 2 or 3, which gives you a win. So is Amy correct that it's evens? No, she's not correct. Give the reason. There is a greater probability of obtaining a 0 or 1 than 2 or 3. Question 9. A drink is mixed in the ratio of lemonade to orange to cranberry of 6 to 3 to 2. What fraction is orange? Circle your answer. Okay, so if the ratio is 6 to 3 to 2, that means there are 6 parts lemonade, 3 parts orange, and 2 parts cranberry. So altogether, how many parts is that? Well, 6 plus 3 plus 2 is equal to 11. So it's 11 parts altogether. Now we want the fraction that is orange, which is the one in the middle, which is the 3. So the fraction that is orange is going to be your 3 orange parts out of your total 11 parts, which is that one there, 3/11. In question 10, we have this electricity pylon, which is not drawn to scale. We've got a little chap down here who's 1.8 meters tall. It says, use the height of the man to estimate the height of the pylon. Oh, happy days. So we need to see how many times this little dude is going to fit into the tall thing. Okay, let's see if I can get the whole of this thing on the page. Okay, so pulling up my ruler. This hasn't got any units on it, but I can see that it's 6 little marks from his feet to his head. Comparing that to the pylon, that is 10, 20, 30, 40, 50, 60, 70 little marks. So the ratio of the height of the guy to the height of the pylon is 6 to 70. So if he is 1.8 tall, then what is the height of the pylon? Well, using the unitary method, we can go via 1. We can divide 6 by 1 and then times it by 1.8 to go from here to here. So we divide by 6 times by 1.8. So we have to do the same to this side. 70 divided by 6 times by 1.8 should give us the height of the pylon. Right, so I'm going to put that into my calculator. So 70 divided by 6 times by 1.8. I make that 21. So 21 meters tall. So I'm going to estimate that it's 21 meters. Now I was using my virtual ruler here that has these little marks on the side. Now if you use an actual exam paper as an actual ruler, your number of marks will be different, I suppose, but the technique will still be the same. If you can write down how many marks you've got for the guy and how many marks you've got for the pylon, and then you can do a similar technique to work out the length. You should get something very close to 21 meters, even whatever unit you decided to use for the guy and the pylon. Okay. Question 11a. Complete the table for y equals 3x plus 1. Okay, so most of the table's been done for us. We've just got a few different values to try here. So what you need to do is take each one of these values of x, sub it into the equation where you see x, and work out what the corresponding value of y is. So for instance, when x is 3, then y is going to be 3 lots of 3 plus 1. 3 3s are 9 plus 1 is 10. Okay, and then when x is 2, y is equal to 3 lots of 2 plus 1. 3 2s are 6 plus 1 is 7. When x is 0, then y is going to be 3 lots of 0 plus 1. 3 zeros are 0 plus 1 is 1. And then finally, when y is equal to minus 2, so when x is minus 2, then y is going to be 3 lots of minus 2 plus 1. 3 lots of minus 2 is minus 6 plus 1 is minus 5. Okay, so they're my points. So I'm going to plot those on the axes. So minus 3 minus 8. Minus 3 minus 8 is down there. Next point, that's that point there, isn't it? Next point is going to be the point minus 2 minus 5. Minus 2 minus 5 is here. Next point, minus 1 minus 2. Minus 1 minus 2 is here. Now, you should notice all these points are in a straight line because it's a linear equation. 0, 1. 0, 1. So if you're plotting these and they're not in a straight line, then you know you've made an error. Next one, 1, 4. It's there. 2, 7. 2, 7 is there. And finally, 3, 10. Okay, so once you've drawn all your points, you can get your ruler out. Line up for all your points and draw a straight line. Looks about right. So your line should go the full width of the graph. Doesn't start and end with the first point. Okay, done. Part C says solve x equals 3x plus 1. Now there are two ways of doing this. We could either do it graphically or we can do it algebraically. Graphically, we've already drawn the line y is equal to 3x plus 1, which is this side of the equation. So y is equal to 3x plus 1. Now if we draw the line y is equal to x, which is the other side of the equation, then where they meet or where they cross is going to be our value of x. So this is the line y is equal to 3x plus 1. Now if I want to draw on the line y is equal to x, now that's going to go through the points 1, 1, 2, 2, 3, 3, which, because the axes are not, or the scales are not equal, isn't the 45-degree line that you might expect. 1, 1 is there, 2, 2, 3, 3 is there, and 0, 0, and so on. So we've got the line there. If I line those up, you can see that it's going to cross my other line down here. Let's just put a fine line on. Okay, so you can see it intersects our line there. It's about at x is equal to minus a half. That's where it's cutting. Okay, so the solution for this equation is x equals minus a half. Okay, now we could also do this algebraically, just by doing the same things to both sides. So here I've got x is equal to 3x plus 1, so I've got unknowns on both sides. So let's take off x on both sides. So that will cancel with that, which will weirdly give me 0 on the left. 3x subtract x is 2x. So I get 0 is equal to 2x plus 1. Subtracting 1 from both sides, I'm going to get 2x is equal to minus 1. And then dividing both sides by 2, I'm going to get x is equal to minus a half, like I did last time. So you can either do it algebraically or you can do it graphically. But either way, you're going to get x is equal to minus a half. Question 12. Jodie's pay is £3.15 per week. She works for 37.5 hours per week. 12a says, work out her hourly rate of pay. Okay, so if she's earned £315 for the whole week, and we want to know what 1 hour is, we're going to have to divide that into our total. So her hourly rate is going to be her total for the week divided by the number of hours that she worked. Time to reach for the trusty calculator. 315 divided by 37.5. I make that 8.4. Now, as this is a money problem, you can't really write down 8.4. It's £8.40. So if you don't write that extra 0 in there to make it pounds and pence, you'll lose a mark. They're a bit funny about these things. 12b, Jodie wants to work out her yearly pay. She says there are 4 weeks in a month, so I will multiply 315 by 4. There are 12 months in a year, so I'll multiply the answer by 12. 315 times 4 times 12 is equal to 15,120. Does a method give a correct amount for her yearly pay? Tick a box. Well, she's used 4 weeks in a month and 12 months in a year. Now, if you multiply those 4 weeks in a month by 12, 4 times 12, you're going to get 48 weeks. Okay, now there are actually 52 weeks of the year, not 48. So, assuming that she doesn't have any holidays and she's working the entire year without break, she will be working 52 weeks and not 48 weeks. So I'm going to tick no, her yearly pay is more. And the reason is there are 52 weeks in a year and not 48. Okay, that's assuming, like I say, that she's working every single week. Question 13. A cube has edges of length 0.8 meters. Work out the volume in cubic centimeters. Now, they put it in bold there, just to draw attention to this. It's like a flashing light pointing to it saying, look at me. Okay, it's cubic centimeters and not cubic meters. This is in meters and we want to put it in cubic centimeters. So 0.8 meters, there are 100 centimeters in 1 meter. So 0.8 meters is going to be 100 times 0.8 or 80 centimeters. So that's 80 centimeters by 80 centimeters by 80 centimeters. So to work out the volume of this cube, volume of a cuboid is length times width times height. For a cube, they're all the same. It's going to be 80 times 80 times 80. Tap that into the calculator. 80, oh, I'm just going to use the power button. 80 to the power 3 is 512,000. So that's 512,000 cubic centimeters. 512000. Question 14. 3 whole numbers have a total of 100. The first number is a multiple of 15. The second number is 10 times the third number. Work out the 3 numbers. Okay, so we're going to have to do a bit of trial and error here to work through to a solution. Let's take each bit at a turn. So the first number is a multiple of 15. So the first number, well, it could be 15, or it could be 30, or it could be 45, or it could be 60, or it could be 75, or it could be 90, couldn't it? So either one of those. So if my second number is 10 times as big as my third number, then it's going to be a multiple of 11, and isn't there, 2 numbers together? Because if you've got 10 and 1, that is. So if that's my second number and that's my third number, it could be 10 or 1, or it could be 20 and 2, it could be 30 and 3, or it could be 40 and 4, it could be 50 and 5. So it's the working out which pair of those goes with my other numbers. Well, 10 and 1 makes 11, 2 and 20 makes 22, 3 and 30 makes 33, 4 and 40 makes 44, and 50 and 5 make 55. So if I used my 45 for my first number, and then 50 for my second number, and 5 for my third number, that should add up to 100, shouldn't it? So it could be 45, 50, and 5. Okay, that adds up to 100, doesn't it? So let's just double check. My first number is a multiple of 45, a multiple of 15. Yes, it is. That was correct. My second number is 10 times my third number. Yes, yes. And they add up to 100 as required. Okay, you seem to have done it. With these sort of questions, just don't be afraid to get started on them. They're a bit daunting at first, but you just need to chuck some numbers down and work it through and kind of home in on the right answer. Question 15. In March, Kim pays the same amount for each song she downloads. She pays £35.60 for 40 songs. In April, she pays 5p more for each song. She has a £30 voucher. What is the maximum number of songs she can download using the voucher? Okay, so let's a lot of information again here. Let's take it line by line and see what we can do with it. She pays £35.60 for 40 songs. So how much is each song then? So in March, she paid £5.60 for 40 songs. So then each song is going to be the total £35.60 divided by the number of songs, 40. Okay, so according to my calculator, 35.6 divided by 40, that gives me 89 pence per song. So 0.89 pence per song. Right, in April she pays 5p more for each song. So in April, each song is going to be 5 pence more, then it's going to be 0.89 plus 5 pence. So that's 94 pence, isn't it? Okay, so she's paying 94p per song. She has a £30 voucher. What is the maximum number of songs she can download using the voucher? Okay, so number of songs is going to be the £30 voucher then divided by the cost per song, which is 94 pence. So according to my calculator, 30 divided by 0.94 gives me 31.9. Well, quite a horrible looking number after that. So I'm just going to round it off to 31.9 songs. Now, obviously, she can't buy 0.9 of a song, can she? She can either buy 31 songs or 32 songs. She doesn't have enough for 32 songs, so she's going to have to buy 31 songs and have some credit left over. 31 songs. So for these sorts of questions, it's about knowing how to round. You know, 31.9 normally rounds up to 32, doesn't it? For like 4 and below, let it go down, or 5 and above, move it up. So you should round it up, but in this case it doesn't make sense, because if I round it up to 32, she no longer has enough money to pay for it. Question 16. Circle the vector that translates shape R to shape S. And we've got some choices below, 4 different choices to pick from. Before we look at those though, let's just draw the vector on. Now, when you're translating, you translate like a matching point to a matching point. So that point on R is going to get mapped down to that matching point down there on S. So drawing the vector on, it's going to be that vector, isn't it, that we're trying to find, this one. Okay, now a vector is written in the form of x over y, which is the distance in the direction of x and the distance in the direction of y. So what is the distance in the direction of x? It's this distance here. So that's the same as going along here and then changing direction and going down here. In other words, it's 1, 2, 3, 4, 5, 6 along and 1 down. Now as a vector then, that's going to be 6 in the direction of x and 1 down. Well, y is normally up, so down is going to be a negative value. It's going to be 6 minus 1. So it's this one here, 6 minus 1. Question 17. How long is side AB? Now, side AB is the hypotenuse in a right-angled triangle. So we could work it out using Pythagoras' theorem, that this side here then, this side is going to be c squared. C squared equals a squared plus b squared, which is 5 squared plus 8 squared. 5 squared is 25, 8 squared is 64, adding them together, 64, 74, 84, 89, isn't it? So c squared is 89, so c is root 89, which according to my calculator is root 89 is 9.43. 9.43. So is it between 5 and 8 centimeters? No. Is it 8? No. Is it between 8 and 13? Yes, it is. Is it more than 13? No. Okay. Well, we did it a long way there, really, didn't we? I think we could have just said, well, it was between 8 and 13 and just guessed. Can't be less than 8 or 8 or less because it's the longest side. So it's got to be more than 8. And it can't be longer than the 2 other sides added together because that wouldn't make a triangle. Okay, so that's the other way of doing it. Question 18. I'm thinking of a prime number. Its digits add up to a square number. Write down a prime number that I could be thinking of. Again, this is a kind of a trial and error thing. I'm thinking of a prime number. What are the primes? Okay, let's just list some of the primes that I know. So you should probably know all the primes from 0 to 100. The first prime is 2, then 3, then 5, then 7, not 9, there was 11, there's 13, not 15, 17, 19, not 21, 23, not 25, not 27, but 29. Let's just stop there and think about the digits of these then. These digits add up to a square number. Well, these aren't going to be any good because I've only got one digit and none of those are square numbers. Let's have a look at the others. So 1 plus 1 is 2, 1 plus 3 is 4, 1 plus 7 is 8, 1 plus 9 is 10, 2 plus 3 is 5, 2 plus 9 is 11. Okay, any squares there? Yeah, that one's a square, isn't it? 4 square. 4 is 2 times 2. So 13 then. 13 is a prime number where the digits add up to a square number. 13. Question 19. Toilet rolls come in packs of 4 and 9. So we can see here that a pack of 4 costs £1.89 and a pack of 9 costs £3.99. Which pack is better value? You must show your working. Okay, so basically we need to find a comparable amount. So either we work out the cost of one toilet roll for each, or we find a common multiple that gives you the same number for each. I think in this case it's probably just easier to divide by the number of toilet rolls because we've got a calculator. So if I take £1.89 and divide it by 4, and I take £3.99 and divide it by 9, I'll get a cost of one toilet roll then, won't I? So £1.89 divided by 4, £1.89 divided by 4, that gives me a per toilet roll cost of 0.4725. 0.4725. Doing the same thing for the 9 toilet rolls. £3.99 divided by 9 gives me for a per toilet roll cost of 0.443 reoccurring. 0.443 reoccurring. Okay, so which one's bigger? Which one's smaller? Well, look at that. The buying in bulk is better value. So the 9 toilet rolls is better value for money. So what's my answer? The 9 pack is better value. Okay, now it said we must show our working, but we've done that. We've done that there, haven't we? So we've shown what you get when you divide. That's enough. Question 20. Increase 4,200 by 38%. Okay, now I use a handy triangle for percentages. Final, original, multiplier. So what have I got? I've got F, O, M to find then. My final is what I want to find. My original is what I'm starting with. That is 4,200. And what's my multiplier here? Well, it's a percentage increase question. If I start with 100%, which I always do, and I increase it by 38%, I've now got 138%, which as a decimal is 1.38. Okay, so covering up the one I want to find, F, tells me that final is equal to the original times the multiplier. Final equals original times multiplier, which is 4,200 times 1.38. Okay, reaching for the calculator. 4200 times 1.38 is equal to 5,796. 5796. Question 21. The table shows information about journeys A and B. Complete the table. Okay, now there's a similar triangle for this as well. DST, distance, speed, time. So that tells you how to find one from the other. So if I want to find time taken from distance and speed, I would cover up the T, and that tells me that time equals distance divided by speed. This is for A. So what's that then? The distance is 32 and the speed is 64. So that tells me that time is 32 divided by 64, which is a half, isn't it? 0.5 or a half. Now that's time, isn't it? So the distance was in miles and the speed was in miles per hour, so that must be in hours, so it's 0.5 hours. So time taken is 0.5 hours. The other one is in hours and minutes, so half an hour is 30 minutes, so it's 0 hours 30 mins. Okay, now the other one, B, is distance. So again, coming back to my little triangle, DST, covering up the thing that I want, it's D. It tells me what to do with the other two, it's S times T in this case. So for B, distance equals speed times time, which is speed 42 times time, 1 hour 20 minutes. Got to take care with this. So we can either write it down 20 minutes, that's a third of an hour, isn't it? So I could either write that down as 1 1/3. I think I might do it like that. 20 minutes is a third of an hour. Or you could say it was 20/60, I suppose. So it's 1 1/3 of an hour. Now, I've got a fraction key on my calculator, so that's no problem. So if I type in 42 times and use the fraction key, for typing in 1 1/3 of an hour, what's that going to give me? 56. So it tells me it's in 56 watts. I've got hours and I've got miles per hour, so that must be 56 miles. 56 miles. Okay. Question 22. 50 people took a test. Before the test, they predicted whether they would pass or fail. 30 people predicted they would pass. 26 of the people who predicted they would pass did pass, and 37 people passed altogether. Complete the frequency tree. Are you predicting that you're going to pass this test? Right, so 30 people predicted they would pass. So prediction, 30 people predicted they would pass, so 30 goes here. So if there's 50 altogether, then in the fail box it's going to be 50 subtract 30, isn't it? Going to be 20 people in there. So 30 people predicted they would pass and 20 predicted they would fail. Okay, so I've dealt with that first line there. 26 of the people who predicted they would pass did pass. So out of my 30 people who said they would pass, 26 did pass. So then that means that 30 subtract 26, or 4 of them thought they would pass, but they didn't, they failed. Okay, and it said 30, so we dealt with that one now, haven't we? So, and then finally 37 people passed altogether. So I know that 26 people passed up here, and I know that 37 people passed altogether. So 37 subtract 26 is the number of people who passed who thought they were going to fail then. So 37 subtract 26 is 11. So if 20 people thought they'd fail but actually passed, that means 9 people who thought they failed did fail. 20 subtract 11 is 9, isn't it? Okay, all done. We're told that a solid cuboid is made of centimeter cubes, and I'm given the plan, the front and the side elevation. Now, in order to get a better understanding of this, I'm just going to quickly sketch a cuboid. You can see my drawing skills haven't improved. So the front elevation is what you can see from the front, and you can see that this is 3 units by 4 units. So this front face here is 3 units by 4 units. Now the side elevation is what I can see from this side here, and that is 3 units by 1, 2, 3, 4, 5, 6 units that way. So we've already got the 3 there, matches with the other 3. And that depth then is 6, and then I can just use the plan view, which is the view from above, which would be that face. Let's just change pen. This is going to be my plan view from the top, and I can see my plan is 4 by 6, and again that matches. There's my 4 and there's my 6, so it all ties in. Okay, so how many centimeter cubes were there to use to make this cuboid? I can just use that by using the volume formula. Volume equals length times width times height. So I'm just going to multiply those three things together. 3 times 4 times 6. 3 4s are 12 and 6 12s are 72. So I'm going to be using 72 little cubes. The times that 80 customers waited at a supermarket checkout, and that information has been put into a grouped frequency table. Now question 6a asks, in which class interval is the median? Now the easiest way to work out a median is using cumulative frequency. So I'm going to add an extra column to my table, which I'm going to put CF at the top for cumulative frequency. Now you get cumulative frequency by adding the new frequency to the existing frequency up to that point. So the first value is going to be 32, and then the next value is going to be 32 plus 19, which gives you 42, 51. The next one is going to be 51 plus 20, which is 71, and then 78, and then 80. Now whenever you're doing cumulative frequency, it's a good idea just to double check your answer here is the same as the one they give you in a question, just as a little check on your own adding up. Mine does, mine works. Now to work out where the median is the person in the middle. So if you've got 80 people, then you can find where the middle person is by adding 1 and divided by 2. So the middle person is the 40.5th person. Now, where do they lie in the data? Well, we can just use our cumulative frequency to work that out. We can see that the 32 people were in the first category, and then person 33 to 51 are going to be in the next category up, and that's going to include our 40 and 41st person. So this group here then is going to be the solution. So let's ring that. Okay, so part B asks, the manager of a supermarket says 90% of our customers wait less than 6 minutes. Does the data support this statement? Okay, so going back to the data, how many people did wait less than 6 minutes? Well, the people who waited less than 6 minutes are going to be all the people in the 0 to 2, 2 to 4, and 4 to 6 category. Now we've already added that up. Our cumulative frequency says there are 71 people who are in those first 3 groups. So we just need to now work out whether or not 71 is 90% of 80. So what is 71 out of 80 as a percentage? Okay, typing that into the calculator. 71 divided by 80 equals, now you see it gives you as a fraction, but if you press the symbolic to decimal button, that converts it to 0.8875 for us. 0.8875, which is 88.75%. Now the question didn't actually ask us to work out the percentage, although we do need to show our method. It asked, does the data support the statement? So having looked at our result, can we say that the manager was correct in his statement? Now actually the mark scheme gives you credit if you say yes or no here, depending on what you say. So you could say yes, 88.75 rounds to 90, so it was reasonable for the manager to say that. Or you could say no, 88.75% is below 90%. Personally, I think the manager's stretching it a little bit here by saying 90%, so I'm going to go with no. I'm going to say no, 88.75% is below 90%. Thomas ran a lucky dip stall. So he's got a lucky dip and he's selling tickets at 50p each. So I suppose he's got a bunch of tickets in the bag. People come along, give him 50p and pull a ticket out of the bag. Now if the ticket ends in 00, they win £12. If the ticket ends in a 5, they win £1.50. And there's some more information underneath. It says there are 750 tickets altogether, numbered 1 to 750. Thomas sold all the winning tickets and some of the losing tickets. He made a profit of £163 altogether. How many losing tickets did he sell? Okay, so to work this out, we're going to have to do several things. And you can see this is a 6-mark question, so there will be at least 6 things we need to do along the way. I think what we're going to need to be able to do first is work out how much he pays out in prize money. And then if we add that to his profit, we'll know then how much money he had altogether coming in. And then we can work out how many tickets he sold. So let's work out how many winning tickets there were to start with. Tickets ending in 00, how many of those are there between 1 and 750? Well, if the number ends in 00, then the first winning ticket is going to be 100, and then the next winning ticket 200, and so on down to 700. So there are going to be 1, 2, up to 7 winning tickets ending in 00. So it's going to be 7 of those. Now what about tickets ending in 5? Well, we're going to have the number 5 itself, and then the next ticket ending in 5 will be 15, and the next one 25, and so on. So how many of those are there? So I suppose up to 95 there are going to be 10 tickets. So there are 10 tickets in 100. So in 700 there'll be 70 tickets, and then there'll be another 5 tickets between 700 and 750. So that makes 75 tickets ending in a 5. Okay, so now we know how many tickets there are altogether of each winning type. We can work out how much Thomas paid out in prize money. So let's just make a note of that underneath. So tickets ending in 00, there were 7 of those, and he paid out £12 on each of them. Now 7 times 12 is 84. Okay, now tickets ending in 5. Now there are 75 of those, and every winner paid out £1.50. So 75 times £1.50 is £112.50. 112.5. So what's the total prize money? Is those two added together. So adding on the £84 is £196.50. £196.50. Okay, so that's the money he paid out. Now after he paid out that money, he still had a profit of £163. So his total income then, how much he got altogether, is going to be his prize money paid out plus the money he's got left over. So his total income for playing the game is going to be his £163 profit plus his £196.50 prize fund, which adds up to £359.50. Okay, so he was selling the tickets at 50p each. So then tickets sold is going to be his total income, £359.50, divided by the cost of one ticket, which was 50p. So he must have sold 719 tickets. Now with these long questions, it's always a good idea just to double check that we've answered everything. And actually, when I go back here, I can see that how many losing tickets did he sell? So I almost missed that. How many losing tickets did he sell? Well, if he sold 719 tickets, and there were 7 winning tickets with 00 and 7 winning tickets, 75 winning tickets ending in 5, the losing tickets is going to be equals 719, subtract the ones ending in 00, of which there were 7, and subtract the numbers ending in 5, of which there were 75. So minus 7 minus 75 is 637. So he sold 637 losing tickets. Now just note how I've set this out. It's not terribly tidy, but every calculation along the way I've signposted what it is I'm doing. This will make it a lot easier for the examiner to see what it is in these longer questions and follow your chain of thought. And actually it's going to be easier for you to, after you've done the question, to go back and check your working and things like that. Your own answer will make more sense to you, so you'll be able to check it more carefully when you come through and do your checking at the end. So just a top tip, just to make sure that you signpost each step of these longer calculations, so it's clear what you're doing. Question 26. Here are 2 column vectors. F is 4, 5, and G is 5 minus 2. Work out 3F minus 2G. Okay, so 3F minus 2G is 3 lots of vector F, which is 4, 5, minus 2 lots of vector G, 5 minus 2. Okay, a bit like BIDMAS here, you've got to do the multiplying before you do the subtraction. So I'm going to multiply these out. So if I've got 3 lots of 4, 5, then 3 times, I'm going to have to multiply each one of these by 3. So that's going to give me 4 times 3, which is 12, and 5 times 3 is 15. So 3 lots of 4, 5 is 12, 15. Subtract 2 lots of 5 minus 2. Again, I have to multiply each one of these by the number on the outside. So 5 times 2 is 10, and minus 2 times 2 is minus 4. So that gives me 12, 15, subtract 10 minus 4. Okay, and then finally we're going to subtract like from like. So the x1 we're going to subtract from the x1, and the y1 and the y1 we're going to subtract as well. So 12 subtract 10 is 2, and 15 subtract negative 4. Taking away negative is the same as adding, so 15 add 4 is 19. So my answer is 219. 219. To write 280 as a product of its prime factors. Now there are different methods for doing this. I quite like the factor tree method, where you start with 280 in a circle at the top, and then you think of 2 numbers that multiply together to give you 280. So I'm going to pick, well, let's go with 2, and 2 times what? 140 is equal to 180. Now, if your number is prime, like 2 is, that's a stop. If it is non-prime, if it's a composite number, then there will be 2 other numbers that you can multiply together to give you 140. So how about 10 and 14? Okay, now 10 is not prime, so it splits up as well. So 10 is 2 times 5, and 14 is 2 times 7. Now 2 is prime, 5 is prime, 7 is prime. So all of my branches are now ended. Once you've completed all of them like that, then you can say that 280 is equal to a product of all those prime factors multiplied together. So I've got 1, 2, 3 2's. So 2 times 2 times 2. I've got a 5 times 5, and I've got a 7 times 7. Sometimes it asks you to write it as a product for prime factors in an index form, in which case you'd have to go one step more and write that as 2 cubed times 5 times 7. Here it doesn't ask that, so either answer would be acceptable. I've got a pair of brackets to remove, so I don't know how you remember this. It might be first, outside, inside, last, might be something like that, or you might have a smiley face. Whatever way, you can work out that you have to multiply everything in the first bracket with everything in the second bracket. Y times y is y squared, y times -4 is -4y, 5 times y is plus 5y, and 5 times -4 is -20. At this stage here, just look in the middle for your two like terms and add them up. So I've got y squared minus 4 and plus 5 make y. So my final answer is y squared plus y minus 20. To work out the size of angle x, and I've been given two sides of a right angle triangle, 11 and 8. So when you've got sides and angles together and a right angle triangle, it's going to be trigonometry. Let's start off by labeling the sides relative to x. So this A is the adjacent, this one is the opposite, this one is the hypotenuse. So we've been given the hypotenuse and the adjacent, and we're wanting to find the angle. So we're going to be using cosine. I don't know how you remember which one it is. I use SOHCAHTOA. Whichever way you remember, the adjacent and the hypotenuse is about the cosine. Cos of an angle is equal to adjacent over hypotenuse. In this case, cos x equals adjacent 8 divided by hypotenuse 11. So we want to find x now, so we're going to type this into the calculator. I'm going to do the inverse cosine of 8/11. So I'm going to type that into the calculator. Inverse cosine of 8 divided by 11, close bracket, equals, I'm getting 43.3 degrees. Incidentally, I am using an emulated version of the Casio ClassWiz in this video. The ClassWiz is a very nice calculator. I've got some videos on using it. I'll put one up in the cards now, and there's more details below. If you're carrying on with A-level maths next year, you might want to consider upgrading your scientific calculator to one of these. It is allowed in your GCSE exams. It might give you a bit of an edge. Next, I need to find length y down here. Now again, I've been given another side and an angle. So again, it's a trigonometry question. So I'm going to label up the sides like before. So this is my given angle. So this one is the adjacent and this one is the opposite. This is the hypotenuse over here. I'm not going to use either of those today. So again, SOHCAHTOA, which one is it? Well, I want the opposite. I've been given the adjacent, so it is tan. So tan theta is equal to opposite over adjacent. So subbing in from our diagram, tan 40 equals the opposite y divided by the adjacent 37. Okay, rearranging for y equals 37 tan 40. Look, I can just take that 37 there and move it up there. That's what I'm doing. And I can type then 37 tan 40 into the calculator, which gives me 31.04 in a bit. I'm going to round that off to 3 significant figures. So I'm going to round that down to 31.0. So my answer is 31.0. 31.0 centimeters. Okay, now with all these sorts of questions, it's always good just to have a quick glance back at the diagram. Does 31 centimeters look sensible in that diagram? So if that one was 31, look, this one's 37, it kind of makes sense, doesn't it? It sits all right in that diagram. It's just a visual check, another way of just checking your work as you're going through. A water tank, which is a cylinder with radius 40 centimeters and depth 150 centimeters. We're told that it's filling at a rate of 0.2 liters per second, and we're being asked, does it take longer than an hour to fill the tank? Well, in order to answer that question, we need to know what the capacity of the cylinder is to start with. So let's do that first. What's the volume of this cylinder? Well, a cylinder is a prism, and the area of a prism is equal to its cross-sectional area times its length, or its height. So we need to work out what this bit is here. Okay, now that area is a circle. It's pi r squared times the height. So the volume of this is going to be, well, that's pi r squared, isn't it? So the volume of this cylinder is going to be pi r squared h. I'll leave the pi in for now. Do I want to leave the pi in? No, let's put it in. 3.14 times 40 squared times 150. So what's that? .14 times 40 times 40 times 150. So that's 753,600. Now that's in cubic centimeters. Now we're told, we should really know this, but 1 litre is 1,000 cubic centimeters. So if it's got a volume of that, then it can hold, let's divide that by 1,000 and find how many litres it can hold. So that's 753.6 litres. Okay, so if it's filled at a rate of 0.2 litres per second, how many seconds does it take to fill up? So time taken to fill up is going to be the volume divided by that flow rate then, isn't it? So taking time is equal to 753.6 divided by 0.2, and that equals 3,768 seconds. 3,768 seconds. Now, this question is asking about time in hours, so we need to convert that to hours. So time in hours is going to be the seconds divided by 60 to get minutes, and then another 60 to get hours. So 3,768 divided by 60 divided by 60 is 1.046 reoccurring, which I'm going to round off to 1.05. So that's 1.05 hours. Okay. So, does it take longer than 1 hour to fill the tank? Well, yes it does, because it takes 1 hour and 5, or 1 hour at 0.05. So the answer is yes. It takes longer than 1 hour. Question 31. The value of a second-hand car is £8,000. Each year it loses 20% of the value at the start of that year. Work out the value in 5 years' time. So this is a bit like a compound interest question, except the numbers are going down. It's depreciation. Now I'm going to use FOM, final original multiplier again. Final amount is what we're trying to find. The original is what we started with. It's 8,000. The multiplier. Now each year it loses 20% of its original value. So we started with 100%, and if I subtract 20%, then each year is going down. So each year is going down 80%, which is 0.8 as a decimal. Okay, so then using the triangle FOM, final original multiplier, cover up the thing I want to find, tells me that it's the other two things multiplied together. So final equals original times multiplier. Now with compound interest, we raise that last one to the number of years. So it's going to be 8,000 times 0.8 raised to the power of 5. Okay, so type that into the calculator. 8,000 times 0.8 raised to the power of 5. What's that equal to? That's £2,621.44. £2,621.44. Well, that's the end of the paper. Not too bad, I hope. Let me know how you did in the comments, and if you have any unanswered questions, why not ask them below. If you didn't do so well, time to hit the books a bit more and then come back and try another past paper in a few days. I'll be here to help you through that one too. And if you haven't already done so, why not subscribe so you can find me again for the next practice paper. Work hard, keep trying your best, and you will make progress. See you again next time.